If you accidentally fall into a black hole, what a stunning sight will you see? The truth may append your perception. In fact, black holes themselves are not black. And it's not a hole either. In Einstein's general theory of relativity, a black hole is a way for space-time to go green. Not even light can escape from its events. The world escapes celestial bodies. And now we're going to take a ride. Spaceship to the black hole. And go on an amazing journey through a black hole. As the spacecraft approaches, we jumped out of the cabin, approaching the black hole under the attractive force of the black hole. But before that, we had to wear a special spacesuit. And that's because black holes are extremely massive. Attraction equals quality. Millions of times the sun, so that all the stars around and matter were captured by him and form a very thick plasma suction disk. And here's what's even scarier. They're spinning at speeds approaching the speed of light. Under constant friction, suction plate surface temperature, it can even reach hundreds of millions of degrees Celsius. It also generates intense and lethal radiation. If you're not wearing a spacesuit, will be instantly evaporated by it. And here's the interesting thing. If you filter across the entire electromagnetic spectrum, after calling up all light except visible light, we'll find in the spectral disk shows a higher energy blue, and the black hole photos previously released by NAS displayed in bright orange. This also means that they're just bright colors, rather than the true colors in visible light. That explains it very well. Why is the higher the temperature constant, the stars glow an eerie blue light? And here's what's even stranger. One side of the suction plate, it seems a little brighter than the other side. In fact, this is due to matter moves very fast in the disk. The right side is approaching us at high speed. All the light waves are added together, so it looks brighter. The left side is moving away from us at high speed, so the light wave is stretched, so that it looks dimmer. This is the magical Doppler effect. If you look carefully, we'll also find there is a distortion in the back of the suction plate. It's like he's folded around a black hole. In fact, it is due to black holes. The attractive force bends the light, like an attractive force lens, so that when we look in a certain direction, what you see is actually lower. At the same time, we will also find the starlight ahead seems to be slightly bluish. Here's why. The black hole's attractive force distorts the surrounding spacetime. The time around us is more distant. Stars are slower. From our perspective, the light from the star is speeding away, which causes a blue spill. And as we get closer to the black hole, you will see bizarre aberrations. That is, the black hole seems to be moving away from us. The reason for this phenomenon is, although we accept it from different directions, the light emitted by the suction disk, but because we're getting closer and closer to the black hole, so much so that the light ahead is constantly shrinking as we gradually accelerate towards the black hole. As the speed increases, the light ahead also looks brighter and brighter. It's hard for the light behind to reach, so it gets darker and darker. This is actually the Doppler effect, the phenomenon caused by. If you look at an orbiting spacecraft at this moment, you will be surprised. The clock inside the ship is also running slower than before, and that's because of the signals that the spacecraft is sending out every second. It takes longer to be accepted. And then we went through the attack plate. At this moment, the disk will gradually disappear from our field of vision as the attractive force increases. All the matter here will no longer be stable orbiting the black hole. It starts spinning faster and gets sucked in by the black hole. After about 2 minutes, we have arrived near the photon layer of a black hole. In this region, anything from the outer light is destined to fall into the black hole. And as we get closer and closer to the black hole, those on board the spaceship saw, our image will gradually fade and slow down until it disappears from sight in the next few seconds. After we enter the photon layer, reach the black hole world. Also from this moment on, beyond the world will forever be our past. Our everything will have nothing to do with this universe. Even if you send signals to the outside world, the signal cannot escape the black hole and reach its destination. So when we pass through the black hole, what will you see? In fact, we can still pick up at this moment, receive light from the universe. You can even see spaceships outside black holes. So we don't even realize it has. Across the world, although on a large scale, the attractive force of black holes, enough to isolate it from the outside. But on a local scale, space-time is almost perfectly flat, and the area ratio is not obvious, so we don't feel changes brought about by the temporal Bay Area. And because of the strange aberration phenomenon, even if we are already in a black hole, it's not going to be pitch black. Opposite image of a black hole. That's only 15% of the field of vision. In the surrounding area of the black hole, you can still see the starry sky. And in the next time we fall into a black hole, the speed of the center will get faster and faster. Even the light behind him seemed. It looks like it's all in our field of vision. Search as the field of vision ahead narrows. The view from the rear will become more and more. The more vast the spacecraft outside the black hole, it's getting bigger and bigger, even as we get farther and farther away from him. The moment we reach the center of the black hole, you will feel a sense of unease. The power of the letter is tearing at the body. Before we even had consciousness, you will. I feel like I've fallen into a world full of darkness, and on a flat surface. In the next 0.1 seconds, our bodies and minds will all be shattered to pieces. Enter the center of the black hole. For us, this black hole journey is over. But for spacecraft outside the black hole, we will live forever in the world. In fact, including modern physics, still can't explain what would happen if you fell into a black hole. But the current theory holds that at the center of a black hole is a spacetime. Go to the infinite starting point of the rate. Of course, some scientists also question the starting point doesn't actually exist. Perhaps only we can combine the attractive forces with quantum mechanics. After unification, we'll completely solve the ultimate mystery.